Hi guys. So this unit is all about naming and writing formulas for compounds. And whether the compound is ionic or covalent matters because there are different rules for writing their names and formulas depending on the bond type. All right, so let's just go to this page here. Hopefully at this point you guys have been working on memorizing that big list of polyatomic ions. If you're kind of having trouble, I just wanted to show you a little way to kind of try to work it out if you're having trouble memorizing. So when you have a polyatomic ion, you want to look at the number of oxygens because there are little families of polyatomic ions that only differ in their number of oxygens, and their name is very similar. So knowing like patterns to look for, you can actually memorize like three or four polyatomic ions because you'll remember they're similar to each other. So if the polyatomic ion ends in 8, that means it's got more oxygens. And if it ends in "ite," that means less oxygens. And 8 is usually 3, the number of oxygens. Oops, I can't spell. Usually 3. All right, so let's look at an example. Chlorate ends in 8. It's got ClO3, 3 oxygens, and its charge is -1. So now if you can remember that one polyatomic ion, then you can remember that chlorite, ite means less, so it has 2 oxygens. So there's 8 versus ite. You can go even further. A lot of the polyatomic ions start here. It's like a group of 2, but you could go even further. Taking away one more oxygen, ClO -1, is we add a prefix, hypochlorite. And if we go one above and add an extra oxygen, it's per. That's the prefix, chlorate. And you guys can find other examples where this works out. Something else to help with memorization, um, as far as the metals go, the transition metals that have more than one positive ion. So, for example, copper can have a +1 charge or a +2 charge, meaning it could lose one electron or two electrons to bond with something else and become stable. So, if copper has a +1 charge, how we write it in the name is copper with a Roman numeral 1. If it's 2, we write it as copper with a Roman numeral 2. Now, you guys are not only responsible for knowing the metals that have multiple charges and what those charges are, but you have to be able to say what their names would be in Latin. Instead of saying copper 1 and copper 2, you can say their Latin names and then you don't have to worry about the Roman numerals. So for copper, the reason why the symbol is Cu is because it comes from the Latin name cuprus, if it's +1, or cupric, if it's +2. And the ending is either us, OUS, or ic, IC. So a way to help you remember this, and this always works for any metal ions that have multiple charges, if it's the lower one, so copper can be +1 or +2. +1 is the lower oxidation state. The lower O has an O in it. That always gets the us ending. And the high, so the +2 is the high, it has an I in it. That always gets the ic ending. Okay, so if a metal has two oxidation states, The lower one will always be us. The higher one will always end in ic when you're doing their Latin names. So that's just another way you can hopefully memorize these a little bit easier. All right, so let's go into naming. Aside from polyatomic ions and metals that have more than one oxidation state, we have ionic and covalent compounds that have nonmetals in them. And when you have a nonmetal in a compound, if it's the second nonmetal, if it's the thing that's written second, we have to change the endings to IDE. So this is a list. It says your IDE guide. These are regular nonmetals. They're just nonmetals in a compound, but when we're naming them, we have to make them end in IDE. So for example, F is fluorine, but when we're naming it in a compound, we're going to call it fluoride. So this is how we change all of the endings to IDE. And you can kind of go through this and figure out what the elements are and how we change them. Okay. All right, so writing formulas for ionic compounds. So what's important here, guys, is that ionic, has a metal plus a nonmetal. So these rules are only going to apply for ionic things. So the first thing it says to do is to write the symbol for each part of the name. So copper is Cu and oxide is oxygen, so O. Now I have to write their oxidation states. So see how they're saying copper 1? That's because copper can have a +1 or a +2 charge. The name has to tell you what charge to use. So I'm going to write +1 for this copper. Now, oxygen, if you guys go to your periodic table, we wrote down across the top what the charges are for all the columns, right? So if you see that oxygen is in group 16, we know, or we memorized, that the group 16 elements have a -2 charge. Okay? So that's what we do. Then you literally take these numbers and you crisscross them and bring them down and you turn them into subscripts. Now, you don't have to bring down the charge, just the number, because it doesn't make sense to have a -2 number of copper atoms, right? So you just bring down the number. And for 1, you're never going to see a 1 written there. When there's no number next to an atom, we know that that's because there's just one of them. And the last and final step is to reduce the subscripts if necessary. If my subscripts are a 2 and a 1, I can't simplify them anymore, so I would be done there. This would be my formula for copper 1 oxide. All right. The next one is a little bit different. I have calcium. Now, nitrate. This does not end in IDE, so that's your clue that this is not a nonmetal. This is a polyatomic ion, right? But the rules are still the same. I write the symbol for the polyatomic ion, so you guys should have memorized by now that nitrate is NO3 with a -1 charge. Calcium is in group 2, so it's a +2 charge. So I crisscross them down. That means I have 1 calcium. Now, guys, when you bring a 2 down or any number down for a polyatomic, you have to put the polyatomic in parentheses and the number, the subscript, on the outside, because that 2 means the 2 on the outside of the parentheses means it goes to everything inside the parentheses, not just the last element. Okay, so those parentheses are important if you're bringing down anything other than a 1. All right, copper 2 oxide. Cu +2. I know it's a +2 because they're telling me it's +2. O -2. If I crisscross, I get Cu2O2, and that I can reduce. And guys, if you can reduce and you don't, then that's wrong. Okay, so 2 and 2 can be reduced or simplified to 1 to 1. It's like simplifying a fraction. Okay, so this one's a little weird because they're saying plumbic sulfate. So now plumbic is lead. It's the Latin name for lead, right? Now, lead, if you're memorizing your list, lead can be a +2 or a +4 ion. So I know that if it ends in ic, I want to choose the high ion. So here, instead of giving me a Roman numeral, they gave me the Latin name, and I'm forced to use the ending to decide if the charge is going to be the low one or the high one. This is a tough one. Sulfate is a polyatomic ion. It's got a -2 charge. If I crisscross, I get Pb2SO4, and now I look at my subscripts. I have a 2 and a 4. That can be simplified to a 1 and a 2. All right, so I'm going to give you guys a few to try, and then we're going to look at some naming. Okay, naming ionic compounds. So the metal always comes first, and you just write the name of the metal. So Ba is barium. Okay, I'm going to skip to number 3, just so that we know if we need to leave a space or not. Look at where barium is on the periodic table. See how it's in group 2? So all of the group 2 metals can only have a +2 oxidation state. They don't have multiple positive charges. So if the metal doesn't have multiple positive charges, then you don't need to worry about a Roman numeral when you're naming it. So here I'm not going to leave a space. This is just going to be barium. And then the nonmetal should end in IDE. So F is fluorine, but I'm going to call this barium fluoride. Okay, nice easy one. All right, let's look at the next one. Na is sodium. Go check to see where sodium is on the periodic table. Think about what group it's in. Does it have more than one charge? No. Sodium is in group 1. They're all +1. That's the only thing they can be. So to write a Roman numeral is pointless. So now, guys, now I don't have just a regular nonmetal. I have CO3, which is a polyatomic ion. For polyatomic ions, you've memorized their names with their symbols. We never change the names or symbols of polyatomic ions. So CO3 is called carbonate. And that's it. All right. Now let's look at this one. Cr is chromium. Now, chromium is a transition metal, so I'm going to need to put a Roman numeral in this name because chromium can become more than one type of positive ion, and I have to figure out what that is. And then Cl is chlorine, but I'm going to name it chloride because my metal should end in IDE. Okay, so how do we figure out what number I'm going to put in the Roman numeral? So that's where rule number 4 comes in. Your compounds are neutral, so the charges of the metal and the nonmetal should always add up to 0. So I know that chlorine is in group 17, and they all have -1 charges, right? But I have 3 chlorines, so that's really like a charge of -3. I want my chromium and my chlorines to equal 0. So if chlorines are -3, then chromium has to be +3 to cancel that out. So because chromium has a charge of +3 here, I'm going to put a 3 in parentheses. Okay? The other way you can do it, guys, is you could use the Latin names. So for chromium, 3 is the higher charge of the 2 charges that chromium could have. So instead of calling this chromium 3 chloride, I could actually just name this chromic for the high. All right. All right, let's do the next one. Pb is lead. Lead is one of those middle guys, so it can have more than one charge, meaning I will need to leave a space. Oxygen is oxide. Okay. So guys, oxygen is -2, but I have two of them, which is really a -4. So what does lead have to be? +4. They have to cancel each other out. So I would put a 4 in my parentheses. Okay. This is also the high number for lead. Lead could be 2 or 4. 4 is higher. So if I was using the Latin names, I would call this plumbic. Ic for high. All right. And the last one is lead again. I know I need a space. O again, oxide. This time, guys, oxygen is -2, but there's only one of them. So this lead has to be a +2 to cancel that out. So since this is the lower lead, I would call this lead 2 oxide, or I could call this plumbus, OUS for low oxide. Okay, I'm going to give you guys some practice with naming, and then in our next video, we're going to talk about covalent compounds. All right.